For today's pre-class homework, I'll talk about the algebra in a test of independence. A test of independence involves two variables, which can be qualitative, meaning not numerical, and it tests whether the variables affect each other. I'll go over what happens if we assume the two variables don't affect each other. The General Social Survey sampled 2,985 people with different marital statuses. 1,413 were married, 256 were widowed, 586 were divorced or separated, and 730 were never married. So these are the totals for their respective columns. And they were asked how happy they were. And some said very happy, some said pretty happy, and some said, not too happy. Of the 2,985 people total, 919 said they were very happy. So there are two variables in this table. One variable is the marital status with 4 different values. The second variable is happiness with 3 different values. And the research question is, does marital status affect happiness? Our null hypothesis would say, well, what if it doesn't? What if marital status does not affect happiness? Specifically, we're looking at people who are married, and we say, if marital status does not affect happiness, what is the expected number of very happy and married people? Hit pause and think about it for a second and resume. And here's the algebra key to what we're doing. If marital status does not affect happiness, then the ratio or percent of very happy people should be the same for all the different marital statuses. The ratio or percent of very happy married people, very happy widowed people, very happy divorced or separated people, very happy married people should all be the same ratio or percent. And it should be the same ratio or percent as the very happy total. And that is the key to the algebra that we'll use, because we will apply this same ratio everywhere. So what's the ratio of very happy total? 919 people out of 2,985. So the ratio equals 0.75292. So if marital status does not affect happiness, we can compute the expected number of very happy and married people by taking the 0.75292 and apply it to the total of married people. 0.75292 times 1,413 equals 435.025. I'll keep the decimals because the expected number is like an average, so it has decimals and we keep the decimals. I'll put the ratio back in the table like that. So 919 over 2,985 times 1413 equals 435.025. That is the expected number of people who are in the very happy and married box, if we assume marital status doesn't affect happiness. And we get that number by using ratios. All right. Let me give you more data. Total pretty happy, 1676. Total not too happy, 390. And those are the respective row total for those rows. And I ask, what is the expected number of not too happy, divorced, or separated people if we assume marital status does not affect happiness? So the same thinking. The ratio should be the same. It should be the same for divorced people as it is for total. So same method, we calculate the ratio for the total and we apply it to the divorced and separated people. The ratio of not too happy people for the total is 390 out of 2985. Apply that to the total divorced or separated people. I get 390 out of 2985 times 586. Or 76.562. And you can use the same logic to fill in the rest of the table. And hopefully at some point, you figure out that you don't need to calculate the ratio all the time. You start to see the pattern as to where all the numbers come from to compute the expected number. Now for some more concepts. First, these numbers that we're computing is the expected number of people for each of those boxes. Number of people is head count, and head count is the same as frequency. So the numbers that we're putting in this table are called the expected counts or expected frequencies. Each of the boxes will contain the expected count or expected frequency. On StatCrunch, it's specifically called expected counts. And second, when we say that we assume marital status does not affect happiness, what we're saying is that we assume that marital status and happiness are independent. And independence implies that the probability does not change. Remember when we did binomial and we had to check the requirements for binomial? And we figured that saying that the trials are independent is the same as saying that there is a fixed P. When the trials are independent, then the probability of success doesn't change. Well, probability and ratio and proportion and percent and all those things mean the same thing. So it all ties in together. All right, so I'm sure you can fill in the rest of the table of expected counts. So go for it. All right, thanks for watching. Bye.